Hi, in the last workshop, we learned about the Millikan oil drop experiment and the Thomson cathode ray experiment. And these two experiments together told us about electrons, and we learned that electrons have a charge, QE, which is minus, and a mass, ME, and that mass is very light. It is 1 over 1,800 grams per mole. So what we know about the atom is very different from the electron. Although electrons were gotten from atoms, we excited atoms to get electrons out of them, an H atom is not minus charged, it's neutral. And it is much more massive than an electron. It's 1 gram per mole. And so we have a question. Where are the plus charges in atoms so that they are overall neutral? And where is all that mass? And the first experiment, which gave us clues as to where the plus charge and the mass is, was the Rutherford gold foil experiment. And in this experiment, you take some gold foil, and gold foil can become very, very thin. We put the gold foil inside a large fluorescent screen. And the fluorescent screen is good because when charged particles strike it, there's a flash of light so you can see it. And we take a stream, which we call a beam, of alpha particles. And an alpha particle is a charged particle, and it's quite heavy. It's 4 grams per mole. So we take our beam of alpha particles and we pass it through the gold foil, which at this point all we know about are that it has electrons much, much lighter than it. And so when the heavy thing encounters a light thing, it just passes straight through, bounces, it moves maybe a little bit, deflects a little bit due to the charge of the electron. And mostly that's what we see. But very, very interestingly, 1 out of every 100,000 times, the alpha particle, instead of going straight through, bounces back. And bouncing back is called backscattering. And what that means is that the alpha particle, massive as it is, must have encountered something even more massive so that when the alpha particle hits it, it bounces back. The thing that it's hitting must be the missing plus particles. And so we know the plus particles, the plus charges, have come together to make something very massive. In order that the alpha particles bounce back. And we now know that that very massive thing is the nucleus. And the plus particles, which are called protons, they have positive charges, are inside that nucleus. There's one more experiment I'd like to tell you about today, which is the nowadays called mass spec. And the mass spectrometry experiment is very similar to the cathode ray experiment. You take a north pole, behind it a south pole that makes a magnetic field. We take a charged particle with velocity v, and we know that the mass times the acceleration is equal to the force, the magnetic force. V and B are perpendicular, so it's the charge of this particle times V times B. And the acceleration, therefore, is 1 over m times q times v times b. And when this experiment was first done, it was done with neon atoms. Neon is the 10th atom in the periodic table. Its atomic number is 10. It has 10 electrons. It's neutral. It has 10 protons. We need a charged particle to deflect, so instead of just using neon, we'll use neon plus. Neon plus has lost an electron, so it's got 9 electrons, so it's plus charge, and 10 protons. And what happens when we do this experiment is very surprising. First, what's going to happen is we deflect, so we use the right-hand rule. The field is pointing like this. The charge is that way. Is that way. And so then the force is down. So it does move down. It deflects downwards. But what's surprising is instead of deflecting just in one beam, it splits into 2 beams with 2 different deflections. Deflection is proportional to acceleration. We know that it's all neon plus. They're all the same number of charges. The charges are the same for all the neons. We've designed the experiment so the neon plus charges are moving at the same velocity. They're moving it through the same magnetic field. If the deflections are different, it must be that the masses are different. And the masses are different, we now know, because of a third particle. Neon has a third particle called neutrons, and there are 2 types of neon with different numbers of neutrons. And the neutrons don't change the overall charge, they are neutral. And so we now know the 3 basic ingredients of atoms. There are electrons, protons, which are in the nucleus, and neutrons, which turn out also to be inside the nucleus, the thing from which the alpha particles bounce back. Great. See you tomorrow.